Okay. So today I request everyone to concentrate more and please raise your query as and when you face any difficulty and keep one calculator, pen, pencil. Okay, because Nyquist criterion is not only difficult from the perspective of learning, it is also difficult from the perspective of teaching. So that's why whenever you need a notes or any calculation, please do it without fail. Okay. So characteristic equation is 1 plus dh. Then what is meant by zeros of 1 plus dh? So zeros of 1 plus dh is nothing but the roots of the numerator of 1 plus dh. Because we already know zeros means it is numerator with respect to numerator, and poles of 1 plus gh means it is obviously the roots of denominator of 1 plus gh. And poles of gh means it is denominator roots of gh. So that is very much clear. So now let us consider some examples and let us write these for the example. Now I'll take an example s plus 2 divided by s plus 1 into s minus 1. So this is our loop transfer function gh, or in some textbook it has been called as open loop transfer function. So if you look at this transfer function, the open loop transfer function has one pole in the right half of S plane. So open loop is unstable. Okay. So now let us write the closed loop transfer function. For that, I will assume the feedback transfer function H is unity. And how do we calculate closed loop transfer function? It is G divided by 1 plus GH. So let me calculate G divided by 1 plus GH by substituting it in the CLTF. So what do we get? S plus 2 divided by S plus 1 into S minus 1 whole divided by 1 plus GH. Then simplify. Okay. Simplifying this, we get S plus 2 in the numerator divided by S square plus S plus 1. Fine. So this is our closed loop transfer function. S plus 2 divided by S square plus S plus 1. So if you calculate the roots for this closed loop transfer function, and in the characteristic roots, we end up with the roots lying in the left half of S plane. So that is very much clear by looking at the denominator. If you want, you can use your calculator and cross verify. So the closed loop transfer function is stable. So here is a catch. Open loop is unstable, closed loop is stable. It is possible. Okay. It is possible because it entirely depends on the dynamics of the system. Okay, dynamics of the system and even the system gain also. Suppose imagine if you have 10 into s plus 2 in the numerator.
Excuse me, sir, we can't hear you.
Can you hear now?
Yes, sir, you're audible.
Am I audible?
Yes, sir.
Okay, fine. Sorry. So if you have a gain, imagine 10 into s plus 2 in the numerator, then it is very much sure that you still will get a negative roots or the roots lying in the left half of S plane. So your stability depends, your closed loop system stability depends on dynamics of the system. So I will make it more general. So next, let us look for characteristic equation of the closed loop, CLTF, the third one. So what is characteristic equation? It is denominator of closed loop transfer function, which is s square plus s plus 1. Okay, this denominator. Next, let us write what 1 plus gh. What is 1 plus gh? So many of you may say it as a denominator of closed loop transfer function, but there is a slight change. There is a slight change in writing 1 plus gh. So what I mean to say 1 plus gh actually is 1 plus the open loop transfer function. 1 plus open loop transfer function, which is obtained by writing this expression. So you will get s square plus s plus 1 in the numerator and s plus 1, s minus 1 in the denominator. So this is actually 1 plus gh, what I wanted to tell. Okay, so 1 plus gh is again a transfer function whose numerator is same as characteristic equation. So we'll come to that point. So now how do you get zeros of 1 plus gh? It is obviously from the roots of this. And what is poles of 1 plus gh? It is the denominator of 1 plus gh. Then what is meant by poles of 1 plus gh? Poles of gh is just the denominator of gh part. Okay, denominator of gh part. So these are little confusing terminologies, and you'll get familiar once we solve some numericals later. That this is essential before proceeding the Nyquist criteria. So highlighting the similar parts, zeros of 1 plus gh are nothing but the characteristic roots or the characteristic equation of closed loop transfer function. And poles of 1 plus gh or the poles of gh are same. Okay, so 1 plus gh is very much related to VOLTF as well as CLTF. I repeat, zeros of 1 plus gh means look at this transfer function. So zeros of the numerator gives us zeros of 1 plus gh, and the zeros of 1 plus gh are roots of characteristic equation or the roots of denominator of the closed loop transfer function. This pink color and pink color are similar. Similarly, the green color, poles of 1 plus gh, that is s plus 1, s minus 1, are same as poles of gh. Same as poles of gh. Now let me take another example. S minus 2 divided by s square plus 2s plus 1. So open loop, is it stable or unstable? Just by observation. It is stable because the roots will have a negative real part and they lie in the left half of S plane. So that is open loop stable. Now how do you get the closed loop transfer function? It is g divided by 1 plus gh. So s square plus 2s plus 1 I have rewritten as s plus 1 into s plus 1. Both are one and the same. So what do we get? We get s minus 2 divided by s square plus 3s minus 1. S square plus 3s minus 1 is our closed loop transfer function. So let me calculate the roots of this. Okay. So there are two roots. One is the positive real part and one with the negative real part. So obviously the system is unstable. Unstable because of the positive root in the RHS of S plane. It's a kind of revision also. Please concentrate. Unstable. And what is the characteristic equation for this? It is s square plus 3s minus 1. Then what is 1 plus gh for this? So let us find 1 plus gh for this. It is s square plus 3s minus 1 divided by s square plus 2s plus 1. Then what are the zeros of 1 plus dh? That is the roots of numerator. Sorry, this denominator should not be written there. Denominator should not be written. And poles of 1 plus dh is roots of s square plus 2s plus 1. Okay, and poles of gh is same. So now comparing pink with pink and green color with the green color. So they are same. So here open loop transfer function is stable, but closed loop transfer function is unstable. So we can't help. System dynamics is like that. So we cannot help that if it is stable in open loop, in closed loop, it is not guaranteed. The last one, s minus 2 divided by s plus 1 into s minus 1. So if we calculate the closed loop transfer function, we get s minus 2 divided by square plus s plus minus 3. So it is unstable both in open loop, unstable in closed loop. Okay. So it is unstable in both ways. Similarly, I will write the 1 plus gh part and then zeros of 1 plus gh, which is numerator of 1 plus gh, and last poles of 1 plus gh and poles of gh. Okay. So just these are all prerequisite. I repeat once again, these are all prerequisites for understanding Nyquist criterion. I mean, for a thorough understanding, these are required. So what is the importance of zeros of 1 plus dh? Zeros of 1 plus dh are nothing but characteristic roots of the closed loop transfer function. So obviously they are related to stability. Stability is indeed dependent on the closed loop poles or zeros of 1 plus dh. And poles of 1 plus dh are nowhere related to stability. So they are not important at all because they are not highlighted in denominator of closed loop transfer function. So what I would like to say is zeros of 1 plus dh and the closed loop poles are same. Zeros of 1 plus dh are characteristic roots or closed loop poles. And poles of 1 plus dh and gh are same. Poles of 1 plus dh and gh are same. So these are some key observations here. So with these observations, we'll move on to the next step. Let us briefly revise what we did in polar plot. What we did in polar plot. Today I'll be a bit slow because I'm not in a hurry. The last working day has been extended, so let us have some more discussion in understanding the concepts. So what was the polar plot? Polar plot was mapping the positive y-axis of S plane or the j omega axis of S plane on the GH plane. On the GH plane. I have not done much numericals because it is just substitution and mapping that anyone can do. So some case it was mapped with this shape. In some transfer function, the mapping was like this. And in the third case, it was something like this. So for different transfer functions, you end up with a different polar plots. Okay, so this is obviously for given transfer function GH. So this we call it as conformal mapping. Okay, so this is what we did in polar plot. So now let us map a closed contour from S plane to GH plane. S plane to GH plane. Before that, let us do one intermediate step, that is map it to 1 plus GH plane first and then let us map to GH plane. Okay, so closed contour in the sense it's not a straight line. Okay, instead some shape which has a same starting and ending point. Okay, so that we can define as a closed contour from S plane to 1 plus GH plane and GH plane. So how GH plane can be obtained, or how GH can be obtained from 1 plus GH? Simplest algebra, just subtract minus 1 from this term, you will get GH. So keep this in mind. GH can be obtained from 1 plus GH by subtracting minus 1. So contour is any shape, can have some shape. So what that contour we can assume is, say, something of the shape like this. So instead of a continuous straight line, this let me map this green color closed contour, and you may end up with something like this. Obviously, right? Because each point if you write, it will give you some shape on the GHP. So the green color points on the closed contour, this is called a closed contour now. This I will map on the GH plane, and I may end up the corresponding points like this. This is one imagination, right? So let us see what happens if I map this contour. So for that, I will take the same example instead of the new one. So let us take this example. Okay, open loop unstable, closed loop stable. The first example. So what we are supposed to do now is mapping of the closed contour from S plane to 1 plus GH plane, then to GH plane. And GH plane is obtained by subtracting minus 1 from the 1 plus GH. Please concentrate. I mean, no textbook has explained like this. I mean, whatever literature I have gone through. So it's a collective experience that I have put here to make things simpler and more clear. So why this one plane to other plane, all this plane, why we need to shift and all? It's because Nyquist has made us to do it. And it definitely has very significance. Some may ask me the question, just by calculation, we are getting the information about stability just by simple calculation. Why to go for Nyquist plot? So it has something beyond that. Okay, something beyond that we'll see in future. So now S plus 2 divided by S plus 1, S minus 1 is the OLTF we are considering, and we have to map the closed loop contour from S plane to 1 plus GH plane. Ganesh, is it visible clearly?
Yes, sir.
Okay. So let us take this S plane. Let us mark poles and zeros. So we have 2 poles and 1 0. One pole is on the right half, another in the left half, and 0 in the left half. So this is our S plane. Now I will mark the closed loop contour carefully with the different points like this. With different points like this. Fine. Let me mark those points as 0 origin, then J, then 1 plus J, 2 plus J, 2, 2 minus J, 1 minus J, and minus J. Because this plane is a complex plane, it has real and imaginary axis. And let me take the shape of closed loop contour as clockwise. Like I assume I am moving in a clockwise direction, and I will number the points as 1, 2, 3, 4, 5, so that it will be easier for me when I start mapping. Any doubts till this point? So just listen to the story, and then you can raise any queries. So these are the S-plane points: 0, J, 1 plus J, 2 plus J, 2, 2 minus J, 1 minus J, and let me write 1 plus GH plane now. Let me write 1 plus GH plane and call this as one real 1 plus GH and imaginary 1 plus GH. Imaginary 1 plus GH. And what is 1 plus GH function now? So 1 plus GH function is just add 1 to GH function. So this is 1 plus GH function. So I want to map S plane contour on 1 plus GH plane for this function. So what is the simplest way? Simplest way is start substituting each point here and map the corresponding point here. So that's it. It is called mapping. So I'll write 1 plus GH here. And first point is, no doubt, it is 0. The first point is 0. So substitute 0 there. What you will get? 0 plus 2 divided by 0 plus 1 into 0 minus 1. So 1 minus 2, you will get the value as how much? Minus 1. 1 minus 2 is minus 1. Next, so this point has been mapped as minus 1 on 1 plus GH plane. So we need to find out minus 1 on 1 plus GH plane. So next, how to map the second point? So substitute J here. You will get all the points. So substituting J here, you will get all the points. So it is just an imaginary value minus 0.5. So next go on substituting the remaining points 1 plus J. So 1 plus J. Okay, so these are the values you will get. So like that, if you proceed for the remaining points, these are the values of 1 plus GH you can get. Then what about the substitution for 2 minus J? So 2 minus J is complex conjugate of this term. So obviously the mapped point will be complex conjugate of this point. So the remaining points I can write easily in terms of complex conjugate. So there is a small typo here. This should be minus J. Okay, this point by 8 point is minus J. So for minus J, you will get plus 0.5 J. All other remaining points are complex conjugate. If you want, you can calculate yourself. Okay, so let us not stop here because these are simplest and these are not required in future also. So just listen to whatever I do. So here, when S is equal to 2, the real value, the corresponding mapped value is 1.33. That is also real value. That's why I have written J0, no complex part. So how do we get these points on the 1 plus GH plane? So I'll start with the 0 first point. It is minus 1. Second point is pure imaginary, minus 0.5J somewhere here. Third one is 0.8, minus 1.4, fourth quadrant. Then 1.33 on the real axis. Okay. So if you join all these points, this is what you can expect. The mapped graph. So the corresponding points are 0 has been mapped at minus 1, that is first point. Then J has been mapped as 0.5J, second point, third point, fourth point, and the fifth point. So 1, 2, 3, 4, 5 are done. Then 6, 7, 8, again 0. If you map, they will be symmetrical to the real axis because they are conjugate in nature. Fine. So for that, let us quickly make a symmetrical pattern. Next, second plane is over. Next, we are moving to GH plane. So GH plane means now we are mapping the S plane points on the GH plane for the GH function. So what is GH function? It is s plus 2 divided by s plus 1 s minus 1. Straight away the given OLTF is GH function. So now if I want to get the mapping of S plane on the GH plane, what is the procedure? Substitute all these points on the GH function. Okay, on the GH function. That's it, very simple. So 0 first, then J second, like that. So it goes on like this. So if you substitute 0, what you will get? 0 plus 2 divided by 0 plus 1, 0 minus 1. So that is minus 2 in the numerator. Okay. So minus 2 in the numerator. Here is some thing to be observed. That is, we subtracted minus 1 from the 1 plus GH. Is it correct? We have a minus 1 here. I subtracted minus 1 here. So I got minus 2. Or as I said earlier, we can get GH plot from 1 plus GH just by subtracting minus 1. Okay. So what I mean to say, no need to substitute every point again. Just subtract minus from 1 from all these points so that you can directly plot the mapping. So let us see. Okay, for this also you will get minus 1 subtracted, the real part, minus 0.5j as it is. So first point has been mapped to this, second point has been mapped to this from S plane. And there is a relation between 1 plus GH and GH. That also you should keep in mind. So keeping this relation in mind, let me write all the points. Let me write all the points, and each S plane point will map to this one. Okay, till the last point. And let me plot on the GH plane now. So it starts from minus 2 now. Starts from minus 2. Then we have second point minus 1, minus 0.5 approximately here in the third quadrant. Then minus 0.2, minus 1.4i in the third quadrant again. Then plus 0.6, minus 0.7i in the fourth quadrant, approximately somewhere here. So I'm making some approximation. And the last one is real value 0.33 on the real axis. So if you join here all the points, this is what we get. First point, second point, third point, fourth point, fifth point. So S plane to GH plane. And this is the direction in which it will move. Okay. And symmetricity again, because of the complex conjugate terms. So this is what we get. Okay. So look at the shape on 1 plus GH as well as on GH. They are very much similar, except there is a shift. So now I write the origin. I'll mark this as origin for GH plane. That is obvious. Origin for GH plane. But this is the key highlight here. I will take minus 1 point on GH plane and write it as origin for 1 plus GH on GH plane. 1 plus GH on GH plane. Why? Because see, the first point of 1 plus GH has been mapped to minus 2. So minus 1 has been mapped to minus 2 because you subtract it with minus 1. Therefore, this origin will obviously map to minus 1 on the GH plane. Okay, and this minus 1, I will say it as origin for 1 plus GH on the GH plane, or shifted origin of 1 plus GH on GH plane. Both are correct. I hope everyone is getting this point. Anybody has any queries? Okay. So map from S to 1 plus GH, S to GH, then compare 1 plus GH and GH. So this is what the work Nyquist has given us. Okay. Before passing the course. Fine. So I repeat again, Many textbooks will not explain this point. Many means I don't know any textbook giving this much clarity. So if you compare 1 plus gh and gh, there is a shift with minus 1 on gh plane. So shift with minus 1 units on gh plane means even the origin will also get shifted to minus 1 if you mark it on gh plane for 1 plus gh. That's it. Fine. So let us make some key observations before proceeding. What is the first one? If there is a clockwise encirclement around the pole in S plane, then there is a anti-clockwise encirclement in GH plane. In GH plane or 1 plus GH plane. Fine. So this is what statement I am writing. So if you have a pole in S plane around which there is a clockwise contour, then the mapped contour is anti-clockwise in GH plane or 1 plus GH plane. Okay. So at this junction, at this point, you just understand if you draw the contour around a pole in S plane, which is in clockwise, the corresponding contour or the mapped contour is anti-clockwise in GH plane or 1 plus GH plane. What is the second observation? GH plot can be obtained from 1 plus GH plot, 1 plus GH plane by adding minus 1. So not just minus 1, I will make it as minus 1 plus J0, which is as good as minus 1. By adding minus 1 to 1 plus GH. Fine. So GH plot can be obtained by adding minus 1 to this. Therefore, the origin of 1 plus GH will get shifted to minus 1 plus J0 on the GH plane. On the GH plane. And the last one, which is important one, is that if there is encirclement around the origin, in 1 plus GH, then there is encirclement around minus 1 plus J0 in the GH plane. Yes, so this fourth one is a very much important point. You map any contour from S plane to 1 plus GH plane, and in 1 plus GH plane, if that contour encircles origin, then it will definitely encircle minus 1 plus J0 in GH plane. Okay, we are nearing to Nyquist criterion now. Okay, so these 4 points we will repeat for the next example. Let us cross verify for the next example. So this is a closed contour as I said earlier. I forgot to write here. So next example is the second one, which we took it from the same set of examples in the during the beginning. So what we are doing now here is we are making S plane to 1 plus GH plane and again to GH plane. We are doing the same circus again here. So I will take S plane, then I will take the closed contour. So mark poles and zeros. There are two poles at -1 and one zero at +2. So I'll take the closed contour again. So now different points I am considering. It's my wish, your wish. So it's the same clockwise contour but around 0 now. That is around +2. The points are 1 plus j, 2 plus j, 3 plus j now. And 3 minus j, 2 minus j, 1 minus j, 0. So let me write down all S-plane points. Then again go for 1 plus GH plane. So 1 plus GH is again, just add 1 to the GH. So I want to make this contour on 1 plus GH plane. Just go on substituting all S values here. You will get the corresponding points. So substituting S equal to 0, the first one is -1. Then substitute the remaining points. So I've done the calculation for all. You can also try it. And the last one on the real axis for 3, the corresponding value is 1.06. So rest all are complex conjugate. These are all mapped points on 1 plus GH. 1 plus GH. So first point is -1, second point is both positive in the first quadrant, third point is again in the first quadrant, fourth point is in the first quadrant. So all first points are in the first quadrant except -1. So if you mark, say approximately on the graph, what shape you will get is something like this. Okay, something like this. Then if you map the other points which are complex conjugate in nature, you will get a symmetrical shape about the real axis. So next immediately go to the third mapping, that is for GH plane. So GH plane, how do we get GH plane? It is by subtracting -1 from 1 plus GH. So all the corresponding mapped points should be subtracted with -1. So cross verification, the first point, if you substitute 0 here, 0 minus 2 divided by 0 plus 1 into 0 plus 1, so the starting point is -2. So -2, which is also -1 minus of 1 equal to -2, subtracting -1 from -1. So this is what we get. Subtract 1 from all the points. Cross verification can be done by yourself. So if you map these points on GH plane, you will get the same shape. Though it doesn't look like a same shape 100%, but you will get 100% the similar shape. Okay. So what is the key observation to be made here? For this closed loop contour and for this zero, around this zero. So the key observation we can write is, if there is a clockwise encirclement, can anyone tell me the key observation? Encirclement around the zero in S plane. In S plane, then there is a clockwise encirclement in the GH plane or 1 plus GH plane. So clockwise encirclement around a zero on S plane gives us a clockwise encirclement in GH plane or 1 plus GH plane. So for 0, clockwise, for a pole, clockwise will give us anticlockwise. Okay, so for this present example, what are the other observations? So what are the other observations? So the second observation will remain same. That is, GH plot can be obtained from 1 plus GH plane by adding -1 to 1 plus GH. So there is nothing new. Second, third and fourth will remain same. So the fourth one is again true for this case also. That is, if there is an encirclement around origin in 1 plus GH, there is an encirclement around -1 in GH. Fine. That is -1 here. So all first observations are over. So next, let us look at the examples we did again. The first example was something like this: S plus 2 divided by S plus 1 into S minus 1. Open loop unstable but closed loop stable. Fine. And this is the shape of the mapping we got from S to 1 plus DH, from S to GH. But what Nyquist uses is, he don't use 1 plus GH. Okay. He never deal with 1 plus GH. But for understanding purpose, I have shown this intermediate mapping. So what does Nyquist do is, he will directly map S plane to GH plane. That's it. S plane to GH plane. And he keeps in mind that -1 is origin for 1 plus GH on the GH plane. That's it. Okay. So we erase this second mapping from our mind. And we add the key point in our mind that on the GH plane, -1 represents origin for 1 plus GH. Let's hold on. What does the Nyquist is going to tell about stability? So this is intermediate step. Because if I directly tell you without drawing this diagram, as -1 is a origin for 1 plus GH, anybody would get confused. So to avoid that, this intermediate step. And similarly, let us look at the second example we did. So what we did is open loop stable and closed loop unstable. Fine. So this mapping is done. Next, we are going to propose or explain the Nyquist criterion. But before proceeding, I will take just 5 minutes break because I have to end up this lecture so that the video can be saved only for 1 hour. Okay, with a less memory. so that you can access it easily. Otherwise, if I take the class continuously, I have to save a video for 2 hours, which will take more memory. So you cannot access it easily. I will end and I will come back by exactly 5:25. Ganesh, is it okay?
Yes, sir.
Yeah, I'll come back by 5:25. Please hold on. Don't leave.